Welcome to Pushing PPFD, how to run high intensity lighting. FOHSE is bringing you this presentation today. We're happy to have everybody. I'll introduce our presenter, Martin, who's the Director of Horticulture here at FOHSE, bringing more than 40 years of experience and a holistic approach to all things horticulture, specifically cannabis, vegetable, cut flower. He's a crop consultant specializing in training greenhouse management, concentrating on root zone and climate management, nutrient management, and he's been a bold addition to the FOHSE team over the past couple of years now. And we're excited to bring this presentation to you where we talk about using high power LEDs and the environmentals that go hand in hand with that. So with that, Martin, if you want to begin walking us through, well, actually, I guess we'll just to kind of give you guys a rundown of what we're going to do today. Martin is going to walk through the presentation, and please post your questions as they arise. Towards the end of the session, we will have a Q&A where we'll be fielding questions. And for everybody who attended, you will get a chance to work with the FOHSE team directly. We'll send out a follow-up in case you want to begin working with FOHSE on your particular situation, where we can meet you halfway with our consulting services. So with that, Martin, I'll let you kick us off.
Yeah. All welcome to the presentation, this webinar. And let's start with everything that we're covering. We start with the science of photosaturation. What is photosaturation? What is composition point? What is saturation point? How do you use light most efficiently? What is, it's not only yield per watt, but also yield per micromole. Okay? So there's different ways in which to optimize your yield and get the most out of the lighting that you are applying to your plants. And number two, the environmental triangle. Okay? So light is one side of the coin. Everything else is the other side of the coin. Okay? So they have to be adjusted and optimized in lockstep. Carbon dioxide, VPD, and temperature, they're all equally important. The law of the minimum applies, Libby's law, and the minimum determines the maximum outcome. So this is something that has to be dialed in together with your lighting intensity. Number three, lighting and environmentals are phase dependent. Veg states, you want to create vegetative, conditions that are good for vegetative growth, for the buildup of the plant, for maximum photosynthesis, and laying the foundation for ultimately what we want to achieve is maximum yield and quality. Okay? So there is a real progression of light and environmental strategies, throughout the development of the plant from start to end. Of course, we also want to look at some facilities where we actually were able to apply some of our protocols, our new ways of looking at things, adding, for example, under canopy lighting. We'll look at some of the yield data, okay, and as a proof of concept. Facility data are mostly from the first trial, actually. So it's not only beginner's luck, but it's dialing in all the environmentals and combining everything in such a way that you achieve your targets. Ultimately, number five is, what is the best way to get the highest yields per mole and per watt? What are your what is the best strategy to apply light? How do you distribute light? Are you still trying to get maximum yield by increasing top lighting, or is distributing light throughout the plant a better approach? At the end, we'll have opportunity to talk about your questions. I'm looking forward to some hard questions. Hopefully, this will be a very good learning opportunity. We learn every time from your questions as well, and hopefully you will learn from this presentation. Over time, when I started out in cannabis, as a consultant, maybe, like 10, 12 years ago, a lot of, I was located in the LA area, and a lot of HPS growers were between, like 7 and 800, 900 micromoles at the max. And that was, great. And then when we moved to LED, it was still about that, although the transition from HPS to LED is somewhat, a learning curve. But via increasing top lighting to very high levels, even up to 1600 micromoles, now we have arrived at what we think is the maximum or the best way, the optimal way to produce and maintain quality is by applying about between 12 and 1300, which is the high range, admittedly, top lighting, and adding any increase in light in DLI by adding under canopy lighting. Okay, so if you would look at a canopy and you would divide it in 3 layers, the top layer is served by the top lighting, and you can only go so far. Once the top layer is saturated, there is no sense in adding more light. And if you look at the middle section, that is an area where light levels are diminishing very, very quickly. You don't get your maximum potential. You don't reach your maximal potential anymore. And the bottom part, the bottom third, is where light levels are actually below compensation point, right? Where the bottom part of the plant becomes a sink. So adding the light in the bottom part where canopy actually is taking instead of producing, it would be the next logical step. And we have found that is actually true, that distributing light is the next best thing versus only increasing light levels from the top. So in order to facilitate all that extra light, that extra DLI, it's not only, light, that drives photosynthesis. It's all the other ingredients that go into it. Then if light does not become the limiting factor anymore, then we're looking at the other factors. And CO2 is an extremely important part of that. Rule of thumb, in our opinion, and in which I think is normal throughout the industry, is to match micromoles or to ppm. So if, for example, in veg you have about 450, 500 micromoles of light intensity, you would not apply 1200 micromoles. You can get away with maybe like 600-700 micromoles of or ppm of CO2. Okay, so but as you increase light levels, photosynthesis is increasing, then the need for CO2 increases as well. A nice way to optimize is to match CO2 with ppfd. ppm and ppfd should be about the same. Over 1200 ppm of CO2, you have a diminishing return on investment, so to say, but so 1200 being about the max, between 12 and 1500 is where we should be at the highest light levels. So now we're talking about the other side of the coin, right? Light being one side, the other side being CO2, VPD, but also temperature. Okay, so if leaning on Levy's law, the law of the minimum, if we increase ppfd, but we don't increase CO2, then we limit our photosynthesis. But another important factor as well is RTR, which is like radiation to temperature ratio. Okay, so there are many protocols in different crops. For example, like veg crops, if you add light, you also have to add temperature, because otherwise your extra carbs are being stored as starch and cellulose, right? So you get fat stems and fat leaves. Okay? But in order to transform all that extra all those extra carbs into flower tissue, you have to increase temperature as well as CO2. And as we go through the growth phases, you go from veg stage, a VPD target of about 1, where you promote vegetative growth, broad leaves. You create that great foundation for flower growth, to 1.5 kPa, in flowering stage, where you promote plants, secondary metabolites, where we promote, like moderate stress, still strong growth, still strong photosynthesis, but with added stress, we promote, secondary metabolite synthesis. From the top lighting perspective, you can go all the way up to 1200 to 1500 micromoles of PPFD, provided that you match your other environmentals with that. And also, of course, as you increase PPFD, you also increase transpiration. Okay, so you have to match irrigation proportionally, and you make sure that that water is available. You match your irrigation strategy and EC to satisfy the plant's transpirational needs. Okay, so all the variables have to move together. There's no the art of the grower to make sure that that he recognizes the limiting factors and adjust accordingly. Okay, now we were talking about increasing PPFD, but in our case, we'd like to promote increasing DLI without saturating the top part of the canopy. I mentioned the top part of the canopy is receiving all the top lighting, the light, but the top layer of the plant will be at one point saturated. Okay, so Bruce Bugbee tells there is a linear relationship between PPFD and photosynthesis in the cannabis up to 2000 micromoles, but that may be true in theory, but in practice, if you go up to 2000 micromoles, you know what happens. You get a lot of heat in the top of the canopy. Your stresses increase. The quality of your top buds decreases. You get foxtailing. There's all types of things that can go wrong. Okay, so, but you can, for example, by increasing the light under the canopy, you can increase DLI to, for example, 60 to 75 DLI without, in theory, without compromising top flower quality, and actually increasing the quality of the flower proportionally and evenly throughout the canopy, top to bottom. And in practice, what we see is when we apply all the different environmentals, like proportionally to each other, we can, the normal result is about between 20 and 30% increase in yield. And that is time again, that is what we see. Okay, so if you apply under canopy light in a ratio, for example, of about 1 to 3 between top light and under canopy light, for example, 1200 micromoles of top light and 400 micromoles of bottom light, then you have increased and pushed the envelope when it comes to like DLI, the lighting integral, but you have not compromised the quality of your top buds. And we see more and more great results when it comes to this approach. Now we come to something that I like showing growers many times is photosynthetic efficacy. Okay, so the left, the vertical bar shows micromoles of carbon fixation. So, in other words, captured CO2 and transformation into, into carbohydrates, through photosynthesis. On the right, on the bottom, we see the light intensity, and the colored lines are temperature. Okay, so I don't know if my bottom bar is covering the temperature, but if you can see the temperature, there is a scale from 20 Celsius, which is, I think this line here, the middle line here, which equates to 68 Fahrenheit. And the top line, the highest photosynthetic activity happens at 30 Celsius or 86 Fahrenheit. But that does not mean, even though the top activity is at 1500 micromoles of light and 86 degrees of plant temperature, it does not mean you get the best results, in your growth. Okay, so this is a theoretical maximum photosynthetic efficacy graph. Okay, but you can also see that between 1000 and 1500 micromoles, that 500 micromole increase, that the increase in photosynthesis only amounts to about 2 micromoles of increased carbon capture. Okay, so 500 micromoles more light and only 2 micromoles more of carbon captured. Well, if you look between 0 and 500, you go from 0 to, let's say, 17.5 or 18 micromoles. So if you put light in a dark spot and go from 0 to 500, you're increasing your photosynthesis much steeper as you go from 1000 to 1500. And this is at 86 degrees plant temperature. And you can see that over 1500, it actually decreases. So if you're in a greenhouse in the summer, the sun blasts on your glass, and the temperature in the afternoon is actually exceeding 86, and it happens very easily. And then with increased light, actually your photosynthesis goes down. And I remember as a grower myself, that quality in the summer decreases. Okay, so then at that point, it's almost better to shade a little bit and decrease the amount of light that is entering or reaching your plant, because at these high temperatures, more light becomes counterproductive, while at let's say 25 degrees or 77 degrees of plant temperature, your photosynthetic efficacy actually increases even past 1500. And this is usually the line you see when people show the linear or close to linear relationship between PPFD and light levels. Okay, but if you run them a little higher, your temperatures, you can actually see that at 1000 micromoles of light intensity, you have at 86 degrees of plant temperature, you have the same photosynthetic efficacy at 2000 micromoles of light at 77 degrees. Okay, so you can manipulate photosynthetic efficacy not only by light levels, but very strongly also by temperature. But this steep line here makes the case for under canopy lighting, of course, because when I measure PPFD in the bottom of the canopy, I usually measure, under the canopy, maybe 25 to 50 micromoles. So that light that is being sent upwards into the canopy is being used very, very efficiently. So this is why under canopy lighting is so, sometimes surprisingly effective. So how do I go about this? right? Where do I start? Where do I end up? Okay, so of course, if you look at number one, your facility needs to be designed properly, right? Um, make sure that your light plan is good, with at least 80% uniformity. Okay, so make sure that your sensors are accurate. Okay, what I see a lot of times, if sensors are not accurate or not calibrated properly, you base your decisions on faulty data, faulty information. Okay, so but make sure that everything is kosher right to start with. Okay, so in the greenhouse when I was a grower, I was like calibrating my RH sensor all the time because otherwise, my windows would open and close at the wrong time. So make sure once you start your grow, trust but verify everything that you have set. Okay, so make sure that all the settings match what's happening in your grow room. You have to be able to trust your facility and that you're hitting your VPD and CO2 targets, okay? Because they are, if not properly dialed in, your limiting factors. Delay per growing phase. Okay? So really understand that a vegetative phase also requires vegetative growing conditions. So that means not too hot, not too much light, not too high VPD, because this is the stage. These are the stages, veg and early flower, where we lay the foundation for ultimately maximum flower development and secondary, like the source materials, the carbohydrates, the storage that are needed when the trichomes develop. Okay, so once the flower is developing, it becomes a great sink. It requires a huge amount of energy to maximize flower growth and trichome development. So all those source materials have to be available. So the plant has to grow to like optimally during those stages. Okay? But once we hit flower and we start to bulk and stack, we really want to increase that light level and really want to hit our targets, our DLI targets, because that's where the rubber hits the road. And again, watch leaf temperature and make sure that everything is within the ranges. What I see a lot of times is that all the environmentals are dialed in, except for when I measure plant temperature, it's way too cool, for example. And when we look back, we think back at that photosynthetic efficacy graph, temperature is extremely important when it comes to photosynthesis and the rate of photosynthesis at a given light level. Okay, so you can really use that as a strong indication. And when I walk around through a greenhouse or a grow, I do take light measurements, but most of all, I take plant temperature measurements to make sure that photosynthesis is in the maximum range. Okay, so number 4, monitor and adjust. Well, this is where the art meets the science, because now, like, a grower needs to be able to evaluate plants properly. Okay? So what is the vegetative versus generative balance at a certain phase of plant development? Leaf width, color, like internodal length, all those things are a indication of what the plant balance is, vegetative versus generative. But there's also another balance, which is strength, vigor, right? Is the plant too strong? Do we have way too thick stems? Is there too much anthocyanin development? Or like, are the stems purple? Then it's time to speed them up a little bit. So that is the other balance. Okay, so again, plant temperature and air temperature are extremely important for that, while the vegetative versus generative balance is more like a temperature ramping issue. For example, activating plants early in the day creates more vegetative growth, activating plants, or creating positive diff at the end of the day. That's where generative growth happens. All those things are steering tools available to the grower, and depending on the grower's ability to recognize the plant balances, so to say, he will also be able to adjust temperature ramping strategies to keep the plant within the perfect balance. And then ultimately, number 5, when we have matched full intensity, the highest possible PPFD, we can apply safely and maintain quality and quantity. Then we use those data and we'll be ready for our next cycle. Okay? So it could be genetics dependent, could be every facility is different. There may be differences in different rooms. Like the one greenhouse is different from the other. So there are no set recipes. It all depends on the grower's ability to recognize, evaluate, and apply. Let's go to some actual growers. Okay, so I visited a Minneapolis MSO, large one, first try with under canopy lights. They increased their light levels considerably. This way, the under light levels were about 350 to 450 micromoles, depending where measured. Increase in yield was about, depending on genetics, between 20 and 28.57 in this case, percent. So that is an excellent result. That is really expected when and if applying the right protocols and recognizing that increased light levels also require increased temperature and so on, and match increased irrigation with increased transpiration. A large Quebec facility tried a couple of times, and they had about a little over 20% extra dry weight. So another example, these people actually remove any bottom part of the canopy. They were testing for a greenhouse facility, and this was indoor, but what they did was see if without any plant maintenance, if they still could get that increase in yield, and indeed it worked. So this was like totally maintenance free, so to say, plant maintenance free. Not that I would do this exactly necessarily, but in their case, it was still a positive result. Another facility, this is actually like more conventional, Loon, Michigan. They actually went from 1,000 micromoles to 1,500 micromoles, and combined with some environmental and irrigation improvements, they actually were able to get a 58% increase in yield. So again, they went from, with top lighting, from 1,000 to 1,500, but by not only increasing, like adding light and leaving the rest, but dialing in all the environmentals, all the different inputs, they were able to achieve 58% increase. And Claiborne in Southern California, this was a bit of an outlier because they increased with enormous numbers. But that again was the combination of increased lighting and temperature. But not only that, we also found that their irrigation and nutritional practices needed improvement. We were able to not only increase based on improved light distribution with underlights, but also improved in general by adapting our irrigation and nutritional strategies. So not everybody will achieve 43 to 68%, but in this case, it actually happened. Like let us know what are your current PPFD in flower right now, and where you are right now in this moment. So under 800 or 800 to 1,000, 1,000 to 1,200, or over 1200. And of course, based on what we just talked about, PPFD or total PPFD or is not the whole story. The most important part we now feel is the distribution of light and how not only we increase light levels, but also make sure that all the factors are dialed in properly, and that lighting being one side of the coin, the other side is equally important, and temperature and looking at the photosynthetic efficacy graphs. Also, increased nutritional needs, irrigation needs, all those things have to be increased in lockstep. And then also temperature ramping and average temperature are the tools that we use to manipulate plant morphology, but also make sure that the energy ends up in the flower instead of stems or in leaves as starches. Of course, our flagship, the ACI Pro Series, and it is 7-channel adjustable. Okay? So, of course, spectral recipes are a strong tool, that we are just, this is something that is just, like lately that we're using as a strong tool. Light level is not, and light intensity is not the only important tool we use anymore. So at FOHSE, we have developed a number of recipes, not only for cloning and veg, but also for multiple phases in flower, to optimize light levels at the same time preventing white tipping, and also making sure that we optimize quality, bud tightness, secondary metabolism, in the latter part of the flowering phase. So there's like real separate, identifiable, like targeted lighting recipes for the different phases in the flowering phase and in vegetative phase that we have developed, and we would love to share with you guys as growers. Summarizing, if you'd like to work with us, if you'd like to get a consultation, if you think based on what you just saw that there is opportunity for you to increase yield and quality, we'd love to get together with you. It is my task not only to give you pre-sales support, but also post-sales. So if and when growers like you, have any questions, lights are installed, or if you run into any problems, we are here as your horticultural guys at FOHSE. We will be able and willing to help you all the way and make sure you maximize investment. We will create custom maps and so on. If you have any questions or any concerns, we will address them for you before and after sales.
That's right. Thank you, Martin. So really at FOHSE, FOHSE came onto the scene. We introduced new technology. FOHSE was one of the first, if not the first, to the game with high intensity LED lighting, bringing that to the industry. And we quickly found out that that was new to many people. I see that for those of you who answered the poll on what your current flower PPFD is currently, by far, most folks are in the 800 to 1,000 PPFD range when it comes to flowering. With FOHSE lights, especially the A3i, which Martin just shared, obviously we can push light levels a lot higher than that. And we found out that we needed to add education, right? We needed to show growers how to work with this technology. And that's why we launched our horticulture department. That's why we offer consulting services. So we don't just sell you the technology. We ensure that you are successful with it. We want to make sure that your first run using FOHSE technology is your best run. And Martin heads up that effort, whether that's phone consultations or as you're getting acclimatized to the equipment, we also make field trips. We'll come out to your facility and help you make an assessment on the spot. As we get into questions here, feel free to chime in with questions. It looks like we've got a couple that have come in here. So Martin, for someone who's interested in under canopy lighting but wants to maintain their current energy budget, is there a benefit to incorporating under canopy lighting for light distribution versus top lighting only if we are going to try and use the same amount of energy?
Yes, and the short answer is yes. We've done trials where we actually removed or lowered the top lighting intensity at the same rate as we added light to the bottom, and we still had a 30% increase in yield. Okay, so in that particular trial, okay, so again, that is not representative for every trial, but just like as you could see on the photosynthetic efficacy curve, that light that is diverted from top light and is being applied to under canopy and targeted into the canopy from below is a lot more efficient than the light coming from the top. And so indeed, using your current energy budget, you could still get a very considerable increase in production and quality. The thing is that quality of the buds will not only happen in the bottom of the canopy, but will be evenly distributed over the whole plant. The plant, like apical dominance as being a strong force within plant, the top cola will also be larger, not only the bottom buds. So it's still like a profitable consideration to add under lights, even though you have to stay with the same power budget.
Excellent. Thank you for that. Another question. I'm afraid of stressing my plants out with high light levels. Other than matching ppfd and parts per million of CO2, how can I minimize stress during the flowering phase to avoid white tipping?
Okay, so white tipping occurs at a red as a portion of the spectrum level of 500 micromoles. So depending on the spectrum recipe, you can calculate where that is. So if you have 1,000 micromoles of light, top light, and the spectrum consists out of 500 or 50% red at 660 micromoles. I'm sorry, 660 nanometers. So then that red level then would be at 500 micromoles. So you would not be able to go higher than 1,000 micromoles to stay still in the safe zone. Yeah, if you increase above that, then either you have to go with a different spectrum with a lower red level, or you can divert some of the light to the bottom of the canopy. White tipping is not a destruction of chlorophyll. It is just a trigger mechanism, just like in, let's say, variegated plants, where a certain part of the plant is not producing pigments. So the quality of the white tipping tissue is the same as the rest of the flower. The secondary metabolites are at same levels. But at the same time, of course, white tipping is undesirable. But if you maintain your red 660 nanometer level at 500 micromoles or below, and you can calculate that from your spectrum and total ppfd, you can stay within the safe limits.
Okay. Excellent. And I suppose that might, using a spectrum tuned light where you can actually change the spectrum versus a fixed spectrum light, would kind of provide you some options for a white tipping scenario. Is that right?
Yes, because for example, if the grower desires to have 1,200 micromoles during the first 4 weeks of flowering, then he can lower the red component to, let's say, 40% and still safely apply 1,200 micromoles. But after week 4, to promote quality, bud tightness, and secondary metabolites, especially terpenes, he can increase the red component again. So growers that I deal with like to increase the red component, once white tipping, the white tipping period, or the danger zone of the first 4 weeks is passed, and then they increase the red as part of the spectrum to promote quality. And usually the higher red spectrum towards the end, just like in nature, there is a shift towards higher red in the fall. It promotes quality, and you get a higher sellable portion of your you get a higher sellable amount per weight that you harvest.
Okay. We've got an excellent follow-up question that kind of ties into where we're going with this. If quality is my main focus, which scenario would provide the best quality in terms of total terpenes? Single tier using the A3i Pro, or two tier using the Scorpio Pro? And just for the audience, the Pro series for the A3i and the Scorpio, the A3i is a 1500 watt Pro series, meaning that you've got 7 channels of tunability between the different spectrums of and nanometers, and the Scorpio Pro is the 1000 watt version of that same light. So they're obviously asking, single tier with 1500 watts or double tier using 1000 watts. Is there a discrepancy in quality depending on either method?
There are a few things, right? So what is the depth of your canopy? For example, if you have a shallow canopy, you may be able to get away with A3i on top only. But if you prefer a deeper canopy, or you want to grow a deeper canopy, then I would go with the Scorpio on top and the UCL, the under canopy light. We also have a spectrum adjustable under canopy light with adjustable red and UVA. So you can actually improve more in that case with Scorpio on top and under canopy at the bottom. Okay, so still coming to about the same total DLI. Again, like A3Is probably will be further, like more, there would be a little more distance between the light and the canopy, because it's a way like stronger light, right? So the light plan will also and the conditions will also dictate which light you use. But when it comes to yield and light use efficacy, grams per watt, grams per micromole, I would go with the second scenario.
And the previous loom example kind of pointed that out. They went from 1000 to 1500 micromoles using only top light, which gave them the yield increase. But to your point, distributing that light between the under canopy lights and the top lights is kind of the going rate.
Plus you preserve and kind of guarantee, or the quality, and the morphology of the top buds. Okay, so really pushing it to the edge may cause a little more foxtailing or looser buds, or weaker pedicels, because of the extra heat. So it's a consideration to make.
And we've got a question that builds on the photosynthetic efficacy slide. You pointed out that 86 degrees Fahrenheit seems to be the sweet spot for photosynthetic efficacy. What should my nighttime temp be in comparison?
The 86 is maximum, but it's not necessarily the best temperature, because you have to consider also that bud temperatures exceeding 79 degrees will be detrimental to terpene content towards the end. So it is like where you kind of work with like what is theoretically the highest temperature when it comes to photosynthesis, but lower it to the point where you maintain quality and and make sure So during stacking and bulking, you may want to it's okay to get close to that temperature, and making sure that you don't get foxtailing and your morphology stays perfect. But towards the end, finishing, you don't want to go there. You want to stay at the max of 79 to make sure that your terps don't waft off. And then your night temperatures, again, that is another whole game, right? So I like to see pretty well flat day and night temperatures the first 3, 4 weeks if you want to limit stretching. If stretching is not a problem, you can go to that, like 4, 5, 6 degree positive diff. But it's also the speed at which you increase temperature from night to day, where you and the timing that is really important. So if you, for example, have a positive diff of 6 degrees, you could use the first 4 degrees to warm up 2 degrees per hour before the lights go on, and the last 2 degrees after the lights go on. And that way you kind of activate the plants before the lights go on, and you will have a more efficient, and better and like more active plant that will like have stronger growth right from the morning. Okay? So you prepare the plants to receive the light during initial flower development. You could argue like a 6, 7, 8, 9 degree positive diff, depending on your conditions, your genetics. But for a brief period, you could create a strong generative impulse by creating like a strong positive diff at the end of the day. But again, don't increase your night temperatures faster than like your ramp in the morning from night to day. Don't make it faster than 2 degrees per hour Fahrenheit or 1 Celsius. And divide it up between before and after lights go on. Okay, so that is to activate your plants, to prepare it for the first irrigation, to make sure that you don't mess with your root pressure. You don't and once flowers start to develop, once they start to grow, and you can actually measure a difference in temperature between the flower and the rest of the canopy, that source to sink movement, that dynamic becomes self-sustaining. So after you see the flower grow bigger, then you don't need that positive diff anymore, and you can start slowly minimizing it, and as to the point where once the flowers are at their desired target size, you don't need that positive diff anymore. You can actually go with a flat climate again. And so, as what you could do is, if your flowers are not reaching the target size, you could actually keep your day temperature extended into the night, after your lights turn off, and keep your plants, keep the metabolism in your flower going for a little longer, and make get some extra growth out of your flower. Okay, so but depends on how you see your flower and where you want to be. Okay, so
Okay. We do have a quick follow-up, and you might have covered it there. The question was if there are optimal night temperatures, which you kind of covered, but specifically in terms of how are you ramping temperatures and light to avoid bud rot? Did the answer you just provided covered bud rot?
It somewhat covers it. Bud rot usually comes from within. Like if you think of tomatoes, right? Cracked tomatoes in the you've seen them those before. Eh? So that is a result of excessive root pressure, and usually that's because you either irrigate too early, or a combination of that and your plant not being active yet in the morning, right? And also, if there's a large difference, like a huge delta in water and feed and the EC and the pot, right? So if for example, flushing at the end of the cycle, if the EC delta is enormous, then the first irrigation, that water is being taken up explosively and ends up, may cause damage to the bud. So that's not a reason why you'd like to activate the plant before your lights go on, and especially before your first irrigation, you got to make sure that your plant is actively transpiring. So transpiration before irrigation, and it's extremely important. And at the end of the day, if you have a huge temperature drop, your RH, your relative humidity may skyrocket as the plant is still actively transpiring or trying to. If the humidity goes to 100%, all of a sudden there's nowhere to go for that water, right? There's transpiration is limited. So again, you get the root pressure peak in the bud, and you may get adverse conditions within the bud. And so usually, botrytis happens at the end of the cycle, right? Right before you I think you made it, right? So make sure it's temperature ramping, timing of the irrigation, EC delta are all extremely important when it comes to bud rot prevention.
And you did ask for challenging questions. I know we're coming up on time, but I wanted to get you this good one.
All right.
Martin, could you talk about a general DLI ramping strategy through flowering from a source sink perspective? And just to kind of give some context, this is a three-parter. The follow-up is, when during the flowering cycle are plants typically most carbon limited, and how should light intensity or DLI be increased as sink demand rises?
Sink demand rises. So the thing is that you actually, like the trichomes are a huge sink right towards the end. So you got to build up that carbohydrate foundation. So during the first 4 weeks of flower, you want to optimize photosynthesis. So you don't want, so it's a confluence of different strategies. You don't want to dry back too quick, stress the plants too early. And that is where a lot of growers make their mistake, is that they stress the plant too early. If you look at a Brix chart, you can measure actually plant health and where you are with by measuring Brix with the sugar content. So if your plants, or if your leaves contain at least 13% dissolved materials, then your plant is probably on the good side. But below that, your plant probably are DLI, they are starving for more light. Carbon limitation is more like a confluence of all the different factors. And how would I explain that? Indeed, a good hard question. But the foundation of the flowers is laid during the first 4 weeks. Translocation of carbohydrates and apical dominance is something that you can manipulate with temperature ramping, right? And so, but once the flower has reached a certain mass, critical mass, that translocation of resources has become self-sustaining. And at that point, I don't think that you really have to look at a DLI limitation. You just try to stay within that optimum range, but you also have to maintain that optimum range of temperature, and have to adjust all the variables, all the inputs, to make sure that there's no limiting factors. Okay, so carbon starvation is to me, that's a new term.
Okay. And there was a part 3. I wanted to save it for you though. So
go ahead.
As we just kind of talked about that, at what point does the carbon demand begin to decline, and when should you typically?
Sorry, I'm not getting it. I think it's a connection issue.
Let me know when you have me again.
I can hear you now.
Okay. The third part, at what point does that carbon demand begin to decline, and when would you typically start tapering DLI on the back end of the cycle?
I like to push until the end, but it is a matter of not only like of the light intensity, but also the light spectrum, because usually a spectrum high in white, low in red is warmer, and also elicits different morphological reactions. So with a 40% red, like or a white spectrum, I like to lower the PPFD once the flowers have reached their mature size, and you want to start working on finishing. Okay, so you lower your temperature not only to preserve morphology, but also drop your temperature and try to elicit that higher anthocyanin, the purpling. But if you work with a higher red spectrum, your photosynthesis is higher to start with because it's a more efficient spectrum. So even with higher light levels and higher temperatures, you still create that excess of sugars, excess of photosynthesis that'll turn into higher production of anthocyanin. So you still get that purpling. So it's also plant genetics, like flower genetics. Some genetics will turn purple even at higher light levels. That's the only thing they need. While others, need that cooler temperature. Okay? But I don't see that for every case, lowering of temperatures, light levels is needed. But I see it more necessary for a high white spectrum.
For someone using our Pro series where they've got the 7 tunable channels, does the answer change when you can optimize that spectrum?
Yes. So if I would run, let's say, 80% red at the end, I would still keep high light levels, and I would still, work on yield and mass, right? So I was part of a spectrum. I was part of a spectrum experiment where the last 2 weeks only red light was given. Okay? So at extended daylight hours even, and it only had a positive result. The mass increased even more. Okay? So, but in general, at higher red levels, you achieve a higher sellable percentage, of the final product. And so what I've seen growers that have both scenarios, like a 40% red, high white versus a high red, and they like the higher red for the last part of the cycle. When do you apply it? And exactly what is the timing? Well, it's up to the grower, right? That's where the art is. The grower observes and evaluates the plant and experiments and knows his genetics. Okay, but somewhere in week 7, I would think about that. Yes.
Well, we want to thank you, Martin, for taking the time to drop some knowledge on the community here. And we want to thank everybody who attended today. We know that we really scratched the surface on raising PPFD light levels. I mean, we covered a lot here today, but I'm sure it begs a lot of questions. We kind of pointed at crop steering. We pointed at environmental controls without diving in too deep. If you are working on a project or your grow is at a point where you think you could benefit from any of these optimizations, do reach out to us. As you can see here on the slide, FOHSE.com. You can go there to initiate the process to get your free light plan. That gets you in touch with our sales team, who will find out which light is correct for you or which lighting system, whether that's overhead or under canopy. And once we start to get that figured out, that's when Martin becomes available to help you optimize what you have, or help you pick what's next to further optimize and develop your grow. So once again, thanks everybody. We appreciate you guys coming out. We will definitely do this again.
It was great to be here with you guys, and I hope that it was educational and it was maybe hopefully creating more questions as well. And we will be happy to answer those in the future.